Hi, welcome to my video on maximum minimum word problems, part 3. The perimeter of a rectangle is 60 meters. Find the dimensions if the area is a maximum. Well, it says the perimeter is 60 meters. And we have a rectangle, and a rectangle is, draw a rectangle. Rectangle has 4 right angles, and a rectangle has a length, a width, and a width. So the perimeter of a rectangle is actually 2L, length, and 2 widths. So therefore, 2L plus 2W is equal to 60. So if I take that equation and I solve it for L, so 2L equals negative 2W plus 60. Divide by 2, L equals negative W plus 30. So it says find the dimensions, give the maximum area. So the area is length times width. So the length is a negative W plus 30 times W. So the area is a negative W squared plus 30W. So that means that W equals negative B over 2A, which is the negative of 30 over A is negative 1, B is 30 right here. So 2 times negative 1, that gives me negative 30 over negative 2, which is 15. And the length is equal to negative W plus 30. So negative of, if the width is 15 and negative W is negative 15 plus the 30, so the length is 15. So the dimensions are, the width is 15 and the length is 15. And again, when this is maximum, that reminds you that you have to set it up in the form of a ax squared, y equals ax squared plus bx plus c in standard form, which I do have right here in terms of area as a function of the width. And then we go negative b over 2a, which is a quick way to find the vertex, the width, and the width that gives you the maximum area. So what's the maximum area? Well, we found the 2 dimensions, so the area is length times width. So the length is 15, the width is 15, so the maximum area would be 225. And again, the lengths are in meters and the area is in square meters. And another way to get the area would be to sub it into W squared plus 30W. So I can work it out this way as 225, or sub it into this formula. And we have the width is 15 that I figured out right here. So we sub 15 into this expression or equation. 15 squared is 225. The negative of that is a negative 225. 30 times 15 is 450. Add, and I get a 225. So it's the same answer. So if I have the length and the width, I can get the area, or I can sub it into this max equation. Notice that it's a negative, so that means if you think about the area starts off and it goes up and then it comes down. So the area is the y, and this is the width, as if you're going to draw a graph. So this is 15, and the height is 225. Or sorry, the area is 225. The width is 15, because that's the vertex, and the area is 225. Number 2, a person is fencing a rectangular property with 100 meters of wire. The property borders on a river which is not fenced. What dimensions will give the maximum area? So what we have is think about it, we have a river, and it says they're fencing a property that borders on the river. So here's the property that's bordering on the river. And they're not going to fence where the river is. So we have a width, and a length. Now, a lot of people will say X, X, and Y, but I'm using W and L for length and width instead of X's and Y's. It's the same idea. Once I draw the diagram, I don't have to say, as I did up here, because I drew the diagram, I have said that this is the width and this is the length, so that I don't have to write a statement out. So they're going to use 100 meters of fencing, so the perimeter is 100, and they're going to fence, the perimeter is 1 length and 2 widths. That means the length plus 2 widths is going to give us 100. So that means L is equal to negative 2W plus 100. So the area is of the rectangle is length times width. So the area, the length, is negative 2W plus 100 times W. So the area is negative 2W squared plus 100W. So notice I have a quadratic, and the quadratic is this is a negative A, so it's again very similar to this. It's going up and then coming down, so it's a maximum. So to get the W, because it's a maximum, talking about maximum area, then W equals the negative B over 2A. So A is negative 2, B is 100. So we have the negative of 100 all over, that's an A, 2 times negative 2, so that's negative 100 over negative 4, and that gives a 25. So the width is 25. And if the width is 25, then the length is negative 2W plus 100. So the width is 25. So we sub 25 in for the width. And that gives us negative 2 times 25 is negative 50 plus 100. So it gives us, the length is 100. So what dimensions will give you the maximum area? The width is 25, and again is in yards, and the length is 50 yards. So notice, if you think about it, we have a 25, a 25, and a 50. Just want to point out, if the rectangle, if it was this 25, 25, 25, and 25, that makes 100. The square is always gives the maximum area. But because we took this side away and we didn't have to put the wire there, what happens is that your diagram goes like this. $25, $25, $50. So the 25 feet of wiring that would have been here is now put here. So you got a 25, and the extra 25 that I took off of this side is now gone here. So that makes it 50 times 25, which is the area, maximum area. And that's what happens when you take one side away and you double your length, therefore the area is doubled. Just want to mention that fact to you. Number 3, we have a diagram. 128 meters of fencing enclose the garden to produce food. If each section is a rectangle and have equal areas, what dimensions will give the maximum area? Well, notice we have a W here, so we're going to put the fencing here. W, W, W. This is the length, so we have another length down here. So the perimeter, going around all this, the perimeter is 128 meters, and the perimeter is, you got one length, you got two lengths, and you have 1, 2, 3, 4 widths. Therefore, 2L plus 4W equals 128. And again, we'll solve it. And I have the area. I want to give the maximum area again. So the area of the rectangle is length times width. So notice the area is a function of the length and the width. So if I solve this equation for L and sub it in here, then the area will be a function of W. So 2L equals negative 4W plus 128. Divide by 2. L equals negative 2W plus 64. So L is negative 2W plus 64 times W. So the area is negative 2W times W, negative 2W squared. 64 times W is 64W. So the area is now a function of the width. And A is negative 2, B is 64. So the width is negative B over 2A, and that's the negative of 64 over 2 times negative 2. So that's negative 64 over negative 4, and that gives 16. And it says that the length is negative 2W plus 64, and W is 16, so negative 2 times 16 plus 64. It's just a dot there. And that's negative 32 plus 64 is 32. And it's in meters, so this is 16 meters, and this is 32 meters. So it says what dimensions will give the maximum area. So the dimensions are, the width is 16 meters, and the length is 32 meters. And if we put it back in, you'll see that 32 is the length. 32 and 32 make 64. There's 4 16s here, 64, 64, plus all these to make 64 is 128. And if I wanted the maximum area, I would multiply these two, and I would get the maximum area. Or if I wanted the maximum area, I would take the 16 and plug it back into W here and here and work it out, and I would get the same as if I multiply these two together. But it only asked me for the dimensions. So that's another video on maximum in word problems. That's on here, yeah. And if you like my video, click the like button, subscribe button, and notification bell. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.